Hello everyone, welcome back to Structure Expert. Today we continue to discuss about big P data and small P data and with how to use it effectively and correctly. In this session we will focus about how to design, calculate P data with a real example. Now let's start with the previous tutorial. When you has when we have a structure and apply horizontal force on a displacement big data, and for the member imperfection or member. Hello everyone, welcome back to Structure Expert. Today we continue to discuss about big P data and small P data with real example. Now let's review about previous tutorial. This is the concept about the big P data. A tall building or a tall frame applied with horizontal force can be wind load, earthquake load. This load will be cause big data. For the small data, you talk about the local member, about wall or about vertical member or about column, long column, or for the member that can be member with slenderness. So we will focus about the long member. In the long column affect the slenderness, so we focus about the small data. And we want to classify and clarify about previous tutorial about how to use notional load in zero code or in AISC or ACI code. It's the similar concept, but it's different formula. This is the specific formula for zero code. For apply for the P data, big P data. Now let's check in the case. Is in the first case we talk about the big P data. To calculate big P data, we have two options. The first one, we can use direct formula according to the code. For the zero code, we can calculate based on the inclination of the structure. Phi is equal to phi 0 multiplied with alpha h multiplied with alpha m. According to the formula, you can find alpha h, alpha m, and the phi 0 equal to 0.005 rajon. You can compute it in the formula to calculate for the phi. Another option, you can use notional load. You can use the magnitude of notional load from 0.2% to 0.5% of the vertical ultimate load combination, the load plus line load. It's important in zero code, the ultimate load combination for gravity load is 1.35 the load multiplied with 1.5 line load. You use the 0.2 multiplied with the load to apply for notional load on each floor. And for SI code, you can use in the range also 0.2 to 0.5 for the maximum. We can another more for the member imperfection. This is the local imperfection. In the local imperfection, you can use the value recommended by code for the steel structure or for the reinforced concrete structure. We can apply L over 400 for the member imperfection, or you can use equivalent load to apply to find initial ball of the member. So you have to remember about two different options you can calculate for the big P data. Big P data you can calculate based on the actual formula, or you can calculate it by using notional load. So in the concept is not can apply each other at the same time. If you use the formula, so you do not need to use the notional load. But it is really hard when you to predict the actual angle or inclination. We can suggest you use notional load in case you apply for tall building or for any building. You can apply the concept. It is very good concept. And for the zero code user, you can use the specific formula, or in the Soviet, in the European country also has their global and local infection in Soviet, so you can activate the option and use it automatically. But if those Soviet don't have the option, you can use notional load to apply on each floor. It is the same concept with the specific formula. You can apply the notional load. We will introduce you one example about how to use the two different, what is different and what is the same when we apply the specific formula and apply the notional load on a cantilever column. The value is similar for the global infection. Now let's continue. And for the load combination, when you apply for the notional load, you can apply for the all load combination for the ACI code. And for the zero code, it's the same concept. Apply notional load with the gravity load. And we review about the previous tutorial classification of the system, frame, non-sphere, sphere, or press and press. We can classify according to typology or deformability. Typology will be on the West rule, but don't forget about the 80% rule. If the pressing system can be received or horizontal force at least 80%, so you can consider that frame is the press frame or non-sphere frame. It is very difficult how to know your structure can receive 80% of the vertical force. It is really hard. By using FEM software, you can use the option. It is very good, and you can perform it by using linear or non-linear analysis. For the concept of 80%, I don't know the whole structure can be received. Pressing system can be received 80% of the horizontal. It is really hard. And for the top typology, you can classify it into press or unpressed according to the presence of core wall, shear wall, or pressing system. Check the pressing system to make sure can receive at least 80% of horizontal force. If we classify according to the formability, we have to check about the critical alpha critical. In the GED, critical load is critical load over 10 or greater than 10. This structure is non-sphere or press frame. You can use a linear analysis, continue to design complete. Is alpha critical less than 10? We have to check about the alpha critical rank 2 or rank in 4 to 10. If rank in 2 or less than 2 or less than 3, you can remodel your structure again, or you can add more thickness on the structure by adding more wall, increase the column section, or adding pressing system to increase lambda critical. And if lambda critical in rank 4 to 10, you can perform full non-linear analysis or second order analysis and design. And to use the option, this is do not forget about the concept of big P data and small b P data. To calculate big P data, you have to apply notional load. You have to apply the notional load. Or you have another option to apply specific formula. According to your code, you can apply specific formula into the structure. Or if you cannot perform or calculate direct in the formula, you have another concept to apply notional load. This option is over here automatic option. You can use the formula, but if in the software don't has the option, you can use equivalent method by applying notional load. And P small data, we concerned about the slenderness, long member. Don't forget about modification factor to reduce axial stiffness or to reduce bending stiffness. We forget about the bending stiffness. And geometric imperfection, we talk about geometric imperfection. We talk about the inclination, but we can use the equivalent method by applying notional load. Okay, to apply notional load, and you can run non-linear analysis or linear analysis according to lambda critical. For the zero code, you can compare the second order moment with the fourth order moment. If lower than 10, this structure is pre-frame or non-spray. If lambda critical greater than 10, you can classify it non-spray. Classify according to the moment and lambda critical. Otherwise, if the lambda critical lower than 10, you have to check about the rank of lambda critical. Now let's check about the amplification factor. We just discussed about rank 2, 4 or 10. Now let's check. Beta is equal to 1 over 1 minus NED over NCO. Is equal to alpha critical over alpha critical minus 1. Now you just apply for the alpha critical 1, 2, 3, 4, 5, 6, 7, and you can find the beta. When the alpha critical is equal 1, beta infinite, no answer, error. When you apply alpha critical is equal to, beta is equal to 3, 1.5, 4, 1.3. And for the sway and non-sway, is the limit in 11. Actually in the 11, alpha critical is equal 11. It's equal 11, so beta is equal to 1.10. 1.10, what does it mean? This is to verify with the second order over one order is equal or greater than 10%. Okay, 1.1. Now we will make an example to see understand about the process or the how we will make an example similar with this cantilever column to make you easy to understand about concept and real problem on the structure on the element. This is the theory. You can review it before we continue to the real practical example. This is a real example. A cantilever column